Jeez. That was pretty sneaky little physics. Okay, let's see. How about
Sucks that in too.
Number 60.
60?
Yeah.
I do want to look at this up.
Oh. Okay, we'll do one more of these, and then then the rest of these are all you.
Oh, this is easy.
Okay, so if this is the function,
Yeah. The curve?
that's f prime, right? Number 60. So if that's f prime, exactly. Now think what this is saying. This is saying that the derivative function is smoothly going from negative to 0 to positive, right? So isn't that just going to look like that? The derivative is it's becoming less negative, becoming 0, then becoming more positive. Okay? Right?
Right.
Okay?
Now, could we do this?
No.
I really think we should do
We
it.
gotta do
It's
calc.
actually really easy.
Oh, okay. Okay, I'm gonna make one up like it.
For the last 10 minutes of class, can we go over this physics thing?
We'll see. No, if we're going to do physics, let's do something really cool, like what we did that one.
Or how about we do something on our homework?
Well, I
We
mean,
get it right.
I almost guarantee you got it right. It's not that bad.
So, can I do it?
Yeah.
Just stop worrying about it.
You probably put a little
Okay.
What number is this one?
This is like 74. Yeah.
No.
Okay, so if we want to turn this into a function, right? So there's the derivative. Now, what do we know about the derivative here?
Where?
What about the derivative during this first part of the piecewise function?
Wouldn't it be a point?
No.
Nope, not a point.
What can you tell me about that function right there?
It's
Up to this point, it's
linear.
pretty boring. It's constant, right? It's constant. Yeah, it just goes forever to the left. Okay.
Yeah, it's a
So,
ray.
so it's constant and negative, right? So
Yeah.
what kind of a function could have a constant negative slope?
A line.
A line. Yeah. So that's just going to be something like this, isn't it? That's going to be, let's say, something that does
Wait,
this.
why does it have to be negative?
Because the value of the derivative is negative. It's below the x-axis.
Oh,
Okay.
that's
Okay.
Okay. And then what happens here?
It goes up.
Okay, it starts, jumps up to a positive value, right?
Yep.
And then, but the value does what?
Decreases till 0.
Ah, okay. So doesn't that look something like this?
Wait, why did...
then it's a horizontal range.
Right, because now, yeah, then that's where it's a horizontal tangent would be right there, because that's where it's 0.
Okay.
Now look at the tangent lines.
Good enough.
This helps. Look at these tangent lines. See, they're starting off being pretty steep, and the values of the slopes of those tangent lines are just getting less and less positive, down to 0, right? And then at 0, it's going to turn around and do something like this. Right now, it's going to go, but it's not. Maybe let me redraw that. Yeah, right? No, because the slope is changing linearly. So it's starting with positive slope, and then the slope is getting less negative with time. Down to, and I don't know if it intersects, it doesn't have to necessarily intersect the x-axis, but I just drew it that way. And then here it becomes positive and constant, right? So it's going to go, hang on a second. I messed that up.
Yeah, you did. It's all wrong.
I messed that up. What should I do instead?
You gotta keep going back.
It's actually getting, I drew it
Greater,
backwards.
it's going greater.
It should go like this.
Yep, you should.
Right?
What are you doing? That was perfect.
right? And then from that point forward, it just goes straight. Like
It's
that.
positive.
Does that make sense? Right?
Just go straight up because it's positive.
It's going to it goes from 0 to get more positive, and then whatever the final positive value is, it keeps that. And I get a constant positive slope, which means a line
I have
with
a
positive
question.
slope.
Why is it curved and why is it not?
Well, it's curved.
Oh, never mind.
It's curved on here because those are places where the derivative is changing. Slope is changing. So it's got to be a curve. It's not curved here and here because the derivative is constant. It's staying the same.
So when it changes vertically, it means the line is curved?
Yeah, because the slope is changing. So the tangent lines are changing, which means it has to have some curvature.
Got it.
Okay?
It has one spot where it has a slope, and the other ones are like,
So only one part of
Yes,
it
you got
just
it.
has a curve.
yeah.
Oh, that one doesn't give you that one, does it? Okay, we'll do that. So 74 would look like this.
You're pretty efficient at making those
I know.
y-axis.
Oh, don't try it at home.
Be serious, don't.
Elsie, I'm gonna be honest. I have not heard you say a single word this entire year in this class.
You're not gonna.
Still hasn't. You're not gonna deal with it. If you could have played for any team basketball, where would you have chosen? Because you didn't play for Stanford.
It could be an astronaut, but
What?
would you be an
Okay,
astronaut?
Jed.
Quick question.
Yeah.
So there gonna be like questions like this then?
There'll be some, yeah.
What's the second derivative of this graph?
Yep. Yeah, these are really important.
You suck.
Okay, so if this is the derivative, then this is, here we got positive constant, right? So it's doing something like, maybe like this, right?
Right.
It's the only function that has a constant positive slope, a line, positive
And
slope.
then it curves and crosses the 0 and then stops.
Yeah, now it's from here, it's going to be
It goes up.
negative to 0,
And then goes up. Nope. Oh, what the?
right?
Yeah, because there's.
I mean, it's hard to, I didn't give myself very much room, did
Why are
I?
you doing that? Why'd you go down?
You're recording this, right?
Well, because look, if it's
Oh,
negative,
because it's negative until
Right.
it's 0.
and then it's 0, and then it's positive up to there, and from that point,
Like a
it just
parabola.
continues like that. Right?
We should do some more practice ones.
Wait,
You should make ones and then have us go up and do it.
how come there's no like separation?
Okay, why would there be? Because all we're saying is this, now, this is just telling us the slope is changing, right? It's not saying that the curve is jumping, it's just saying that we're going from a constant positive slope, all of a sudden we're gonna change gears to a negative slope, so that's just a sharp corner, right?
Yeah, but wouldn't that still be a positive slope because it's positive?
with 2 and solve it.
No, look, you gotta take a slope. The slope becomes negative and big. The slope is gonna start on this interval right here, look what's happening. On that interval, we know it's doing this because it's starting with a negative slope and ending with a positive slope, going through 0. So right there, where the slope is 0, I have to have a horizontal tangent line, right? Okay. Okay. This is pretty important, actually.
Let's try some.
This is stuff that carries over into physics a ton.
Put one up there and then have
Okay,
us
I'll build one. You gotta figure it out.
Any basketball team, though, who would you have played for?
Stanford.
Well, you didn't, so
I
you
know.
can't go back and choose that now.
Would you? If you could do it again?
If I could have, I would have.
You don't think you could have? Did you at least try? Did you try out or anything?
No.
Well,
Why?
Why?
Were you scared of failure?
If you go to the NBA,
I don't know the meaning of failure.
I would have failed. I would not have. I would have.
I'm just saying, you don't know that.
Yeah, it wasn't worth the effort to me.
What?
It wasn't worth his time. His time was more valuable.
Okay, here's what I want. I want this.
yeah, David Beckham or Sean White.
What number is this?
We're just doing that. Somebody's gonna go up there and do it. Like you. You're up first.
They already got
No.
it.
Yeah, I already got to go. Do this. Do you like how you
I have 8% on my battery.
who's in the
They're not consistent.
Okay, I double dog dare you.
Yeah, because he's in college.
integral?
So if you had f prime, f would be the integral.
Yep.
Nice.
Yep. So we'll look at different kinds. We'll look at indefinite integration and we'll look at definite integration.
Bye.
Okay, so let's try this now. We want to analyze this function, right? And then we won't get through. Oh, how much time we got? We'll get started. And then I'll save this
10 minutes.
We get going a little bit on this. Okay, so if this is our original function, then
Just call them up and they can do it.
okay, if this is our original function, let's look at, before we jump into the derivatives, let's look at the domain of this thing. Any places where it's undefined?
Nope. Yes, there are.
Yeah. Not if x is 0, but
Where x is 1.
1
okay, or
plus minus 1.
Negative.
Yeah.
Plus minus or minus 1.
okay, reason being
Can't divide by zero.
that whatever's in the bubble
What is that in time?
cannot equal. That's just a semicolon.
Yeah.
Whatever's in the bubble can't equal 0,
That is not a semicolon.
right?
That's an imaginary number.
Yeah, it's not. So then if I solve for x, that means x squared cannot equal 1, so x cannot equal plus or minus 1 if I square root. Okay? Now, what's happening at those places?
Critical numbers. Just not critical numbers.
Ah, okay. Okay, why? Why are those vertical asymptotes?
Because it's the 0 at the bottom,
0 at the bottom, but not the top.
but not explodes.
Okay, good. So those are vertical asymptotes. Okay, good. We also know something else about our function here. We can find out about the horizontal behavior. Now, are there going to be horizontal asymptotes on this?
Yes.
No, because if I take the limit of the function as x approaches positive or negative infinity, what happens in the case that the top is higher power than the bottom?
0.
Blows up. Okay, blows up. But you might remember, last week we talked about a special case that's still helpful to us. So everybody get this. Focus on this part, because this is something that people have trouble with. If we have a rational function where the top is one order higher than the bottom, when I divide this out, I end up with a line, right?
Polynomial
And
division.
so I'm going to get that slant asymptote, right? So
Right.
let's divide this out.
1.
So if we get, we'll go to the other page to do the division.
Are we going to do some polynomial division?
We are. Maybe we'll
Or
even do
synthetic.
synthetic division. Okay.
Go big for the home, right?
So that's right. So what's that equal? Okay, now we know we could divide this out as using polynomial division. That's fine. Or we could divide the factors. We know what the two factors at the bottom are, right? The bottom, is this going to work? Yeah, this will work. X cubed over x plus 1
X minus 1.
and x minus 1. So let's separately divide those in, right?
Right.
Okay. So then we'll get, if we do this synthetically, what are the coefficients of the polynomial?
1.
Okay, 1 x cubed,
0.
0 x squared, 0 x, 0, right?
Right.
We're putting in the zeros of the denominator. So first we'll put in the 0 of x plus 1, which is minus 1, right?
Right.
Okay, we put in the zeros of the factors in the denominator.
So negative 1.
Now we already know that's going to be a 0, right? We know it, or no, we don't.
No, you don't know that.
We don't know that. In fact, this is going to be probably, something doesn't seem right about
Why
this.
don't
to
we just
me.
do polynomial division?
I think we're going to have to. Hang on a second.
Or wouldn't
Yeah, we would.
You feel more comfortable doing polynomial division.
That doesn't seem right. We're going to get a remainder, and that's not going to be helpful. No, we don't want to do synthetic division. Bad idea.
Bad idea.
Synthetic division, what I was doing wrong there, that didn't seem right. What I was doing wrong there, synthetic division would be helpful if we knew we had zeros. if those were factors of the top also, right? But they're not. So we'll do this long division.
Wait for that to
Okay, so if I divide this in, how many times does x leading term into leading term? X squared times what is x cubed? X.
72.
So if we distribute that, I get x cubed minus x, right?
Why?
You give an X.
Oh.
I'm going to subtract that whole thing. Okay, and I end up getting 0 minus
So regular
negative
x.
x is x.
X.
Okay, now that's my remainder, isn't it? Because x squared will not go into x. So that's the remainder, right?
Real numbers.
And so what this is really equal to then is just this. I end up with the answer x plus x divided by x squared minus 1. Right? That's the polynomial part, and that's the remainder that's left over.
So why did you do that?
Okay, so here's why I did that. So now if I take the limit, so this is another way of saying f of x. So the limit of f of x as f of x approaches plus or minus infinity is the limit of x plus x over x squared minus 1. Okay, now watch what happens. In the limit, what happens to this quotient as x approaches plus or minus infinity?
Goes up.
No, if the bottom is higher order than the top,
No, 1.
it gets smaller, goes to 0, right? So that goes to 0. What we're left with is the answer x. So there's our slant asymptote. Y equals x.
Roger, Dad.
Okay?
Where'd you go?
Okay, so we got a slant asymptote at y equals x. We've got vertical asymptotes at plus and minus 1. That already gives us a pretty good idea what this thing looks like. Right? There's the skeleton of the function right there. Okay, we just got to fill in the blanks. So now we can do the calculus. So if we want to find everything, so we got to find relative extrema, right? So let's differentiate this quotient.
3x squared.
Okay, so I got, let's see, I'm going to have differentiating a quotient. I've got the bottom
Let's skip a step.
times the derivative of the top, which is what?
3x squared.
3x squared. Minus top times derivative of the bottom, which is 2x,
Plus 0.
over the bottom squared. Right?
Yep.
Okay. So let's simplify. Now we could actually, why not, factor out the greatest common factor. I could pull out an x squared from both sides, right? Okay, so that's going to give me x squared times what? Here I'm going to get 3x squared minus 3, right?
Yeah.
Right, Tanner? Right? Right?
Yeah.
What about over here? If I take out an x squared, I'm going to get minus, you're left with 2x squared, right?
Yeah. Oh,
You're wrong.
Okay. And so I get x squared, 3x squared minus 2x squared is x squared.
Yep.
I
Minus
wanted to
3.
do it right.
Okay?
Yep, good stuff.
Okay, good. Now that's really helpful. We got our derivative in factor form, right? Okay, so no surprise that if we look back at the original function, we had vertical asymptotes at plus and minus 1. The original function was undefined there,
Question
right?
mark.
Yeah.
Well, why did... Never mind, you're combining terms.
Okay. So, yeah, just combine like terms. So then the bottom is undefined, same places. Isn't that exactly what I told you yesterday or the day before? I can't remember. The function is going to inherit the discontinuities, the derivative from the function. So that those are not critical numbers because the function's not defined there. But where does it equal 0? Well, at x equals 0, or where would this factor equal 0?
Plus or minus 3.
Plus or minus square root of 3.
Square root of 3.
Okay, we'll pick it up tomorrow. We'll finish this one up. This is a good
Wait,
one.
write that. You gotta write that. Plus or minus square root of 3.
Okay.
Ah.
Okay.
What's the